So people who watch my channel will know that I have a previous video project making a battery dispenser, and in that video I commented on a couple of what I consider to be downsides to the design, not insurmountable ones, but less than desirable characteristics. One of which was that I found that I had decided to magazine load the AAA and AA cells, which turned out to not work that well on a dispenser of this height. It worked well when I made a test only going about a third or a quarter of the height, and the batteries fed fine, but when I got to the full height there was so much downward pressure and friction from the magazine loading that they wouldn't feed properly, and I'd have to kind of bang the side of the dispenser and tap on it to get them to drop down. That was not ideal. I decided to give up on the magazine loading, and I've already made a couple of spacers, as you can see here, where I made the channels narrower so that only a single column of AAA or AA cells line up in there, and that solved the feeding problem, of course at the expense of not storing quite as many cells in the dispenser. The other thing that I've been plagued with since I've started to use this a bit more is when I'm loading it with batteries, I go buy a pack of 16 or 20 cells, especially with the AA's and AAA's that I most frequently use. When I'm dropping them in there, some of them drop down vertically, some drop down backwards, some drop down in other ways, and I keep thinking all I can do is use my push stick to go in there and jimmy them around. I kind of have to do them one at a time, and that's not ideal. And I keep thinking, boy, it'd be nice if I could just reach in here and finagle them with my fingertip as I'm loading it. Of course, I've got this clear plexiglass or Lexan face on it, and I thought, well, you know, how can I get the best of both worlds? I don't want to have an open front because then the cells can flip out or slide out too easily. I need something on the front, but there are other designs, and I'm thinking that what I really want to do is slot these so I can load them in on some sort of a little key and then lower them into position so they don't flip around, and also get control for any ones that might hang up or whatever. So I've got this piece of plexiglass slash Lexan. I'm still thinking it's Lexan, and the first thing I'm going to try to do is just cut it into pieces. I've already got screws for the outer rails or outer spacers and the center one. I have enough screws to put additional ones here, here, and here, and the first thing I'm going to try to do is just see if I can cut this plastic adequately to make it into small strips that overhang the separator spacers, but just enough to keep the cells from coming out, but still leaving enough of a gap to get in there and manipulate them. And if that doesn't work, if the plastic cracks or shatters or doesn't machine adequately, then I'm going to go to using some, you know, thin craft slash aircraft plywood and make the spacers out of that, or the whatever you want to call them, the barriers on the front out of the plywood. It'll be less than ideal, but first things first, tried it with the plastic and see how it turns out. I've decided to make the channels 1/8 of an inch inboard of the spacers for the 3 smallest sizes of battery, and then for the D's and the 9 volts I'm going to 3/16 of an inch inboard. So I got those marked at the extremes. I've also marked places where I'm going to put through the screws to hold these in place. So I'm going to pre-drill those just to get a better alignment. Then I'm going to try actually marking the saw lines and starting to cut these, see what happens. Alright, all the holes are drilled at this point. So I've marked all my cut lines here, and I've also marked each section that I'm going to keep so I don't lose track of which one's which. It also helps me keep track of which side of the cut line I'm cutting on. I always want to cut on the side of the line opposite the section that has the numbers. the bandsaw, even with a moderately coarse woodworking blade, cut that plastic very nicely without chipping, so that was a pleasant surprise. So here are the cut plastic pieces. They're not bad, but I do want to sand them just a little bit to make them look a little more attractive. The cuts are pretty straight. I did it by eye because everything was slightly skewed. I hadn't really squared up the whole battery holder when I glued it together, and there was a very slight skew to it, so I couldn't use the rip fence to cut straight. I just had to sight along the lines, and that worked out just fine. But as usual, you've got the slight nicking from the saw blade that I'd like to try taking down with the belt sander. And instead of using my more aggressive oscillating belt sander on the spindle sander table, I'm just going to use this regular belt sander, which has much finer paper on it. I need to make sure my table's reasonably square first, but I protected the plastic against scratching by putting some masking tape over the small table here. Alright, I have 3 of the strips that have been cut and sanded. They already have holes in them. I have 3 more that have been cut and sanded, but they only have the pilot holes, so now I need to open those up. And I'm going to drill through onto my backing board so I don't do any more damage in the drilling process than necessary. So now I've got the plastic strips on there, overhanging and preventing the batteries from coming out but still giving access. And now I think what I'm going to do is make a couple of little tools that can go in there and manipulate the batteries. So I've decided I'm going to make a two-sided or two-ended probe that can go through the slots that I've just made and support the batteries, you know, 2 or 3 at a time, whatever, as I lower them down and then be pulled out, leaving the batteries in place. And I've got some scrap 16th inch thick aluminum from the hardware store. Got it for some other project. It's in my junk box. I think I'm going to use this. I figured I need to get one probe about 3/16 inch wide and the other about 5/8 inch wide, and each one about 3 inches long, with a wider section in the middle to grab on just for convenience. And I've got the aluminum marked up for cutting. So there's the rough cut tool. Now I have to make some fine adjustments to the dimensions. I wanted it to fit tightly into the narrowest one of these, which is the AAA's, and it mostly does, but it does bind right in the middle, so I'm going to take it down ever so slightly, and it'll work fine for the AA's. And then the wide side will go in the C's and obviously the D's, and it'll fit the 9 volts as well, no problem. So the other thing I want to do is see how far I actually want to make these in terms of depth. I don't want it to go down so far that the wide part scratches the plexiglass, but this is the deepest one and it's a little bit too long, so I'm going to trim that, and then I'm going to do the same thing for the narrower one. Alright, here's the completed tool. Cut it out, rounded the corners, filed the edges, and wire brushed it for a more lustrous finish. And slides through there just fine. And obviously it'll go through there. And it's always deep enough to reach the back without the middle part of the key scraping the plastic. Alright, so now I'm going to see how well this new arrangement works out. I'm going to start with the AAA's. So I, oops, clumsy me. Start with the key just a little bit below the top and keep lowering it down as I add new batteries. At some point, I let it go all the way down to the bottom. I don't need to support all of those at one time on the key. I pull it down here and then just withdraw it. So far, so good. Now for the double A's, see how well that works. Because it's the 16th inch aluminum, it's strong enough to hold a fair amount of weight. It's not going to bend under just a few batteries' weight. This is so much better than the other way. Now going to the wide side of the key. And I found another double A in my pile here. Stick that in. D cells. Another C cell or two. And now for the 9 volts. Well, that's clearly the way I should have done it the first time. It's immeasurably improved. It's so easy to use now. It still looks good. Took a few more cuts than it would have taken if I'd known to do this the first time, but it came out fine. Nothing difficult about this, and every part of it is something that could be reasonably done in some variation of this by pretty much anybody with basic woodworking tools and access to a hardware store. And this little key here, I'm thinking it'd be kind of slick to be able to attach it to the bottom of this door and have it clipped, but I think that's more work than it's worth. It's just going to sit up on top there.